Yeah. In the last class is transformations key comma value pairs. I was discussing the difference between reduced by key and group by key, right? Reduced by key, it performs all the similar keys and aggregates. But group by key, it creates one like a iterable object. It creates like a list object, right? On that, if you apply all types of aggregations, we can perform like sum, max, min, right? The next, similarly, right, I'll come back to this more discussion on this reduce by key, group by key. But before that, we have got some more key comma value, right? Sort by key. One second. Sort hyphen dfs dot sh. Next is like sort by key. B capital, B in uppercase, sort by key. These are case sensitive, right? These are inbuilt functionality, sort by key. Sorting based on key. Sorting based on key. For example, if I'm taking this data, Control Shift T, one more terminal for this Pyspark. Yawn.sh. So previously, just I was discussing right that yawn. Whenever we start yawn, start hyper yawn.sh, right? Two things. Resource manager will be running. Node manager. Resource manager is the master. Node manager is the slave level. Node manager will be responsible for executing the task. Resource manager will be responsible assigning the tasks. In that, we have got two sub services. I said application manager and resource scheduler. And this node manager and application master will be at the slave level. It will be responsible for executing this, right? Jobs. Mhm. Now, say PySpark. So sorting based on, I'll take the same data. sc dot parallelize, a list of tuples. Yesterday we have taken this, like department numbers and salaries are given. I'm parallelizing a list to a Spark object. So parallelizing a list to Spark object. Here I'm pasting the same. Control L, just observe this sc dot parallelize. R1 is an RTD, right? R1 is an RTD. Mm. So 11, what are the keys available? This key and value, key and value, key and value. All the keys sorting based on keys 11, 11, 11 should come, 12, 12, 12, 13, 13, 13 should come, right? So R1 dot sort by key, sort by B in uppercase, sort by key. R1 only on RTDs we can apply these transformations. Whatever we are discussing, right? Only on RTDs we can apply. And the two on the RTDs, the two key comma value paired RTDs only, not on normal RTDs. The RTD should be of key comma value type. And that only we can apply these things, right? Normal RTDs, it gives error. RES dot collect result dot. RES is also an RTD, right? An RTD, if I'm performing collect, you will get a Python object, right? Yes, list. You can see this output, right, in list format. 11, 11, 12, 12, 13, 13. Yes.
So is there any other condition if at all you want to sort based on a specific column instead of the sort by key?
Sorting based on what
Any
is
other column like salary, example. Example, if I want to sort based on salary rate, so sort
it?
by key will not be used, right?
Yes, yes. So we have got data frame concepts, is data frame concept, right? Yeah. We have got the data frames, Spark SQL, right? I'll be discussing in Spark SQL, data frames. In the data frames, many APIs are given, right? Many inbuilt functionalities are there. Sorting based on a particular column. Data frame itself is a row and column format, like a tabular structure you get, data frame, right? But here you won't see the tabular structure. In data frame, you will see the tabular structure based on column you can sort. Like, and you can perform pure SQL queries also of that by creating temp tables. Another on temp tables, you can performing SQL kind of querying also. So sorting based on keys only. Here, this functionality, just I'm discussing about this functionality, which can sort only based on key. Now, see the next one. This all should be applied on key comma value paid only. Map values, V in uppercase. Map values. Map values, right? Yes. Applying a functionality to each value. Applying a functionality to each value without changing the key. Without changing the key. Observe here, map values means applying a functionality to each value without changing the key. For example, same thing. So parallelize this. R1 is an RTD. R1 dot map values. R1 is an RTD. In that map values, V in uppercase, map values. For each value add 5,000. For each value add 5,000. How can I add? Only values to values I want to add.
Lambda,
Yeah,
lambda x.
lambda x, yes. Lambda x, x plus 5,000. I want to add 5,000. X plus 5,000 means only to the values it is going to get added. RES. RES equal to R1 dot values. RES dot collect. RES dot collect, right? You can see. Yes. Yeah, 1 second. Okay. Adding 5,000 to each and every values only, not the key, right? Yes.
Vijay, I have one doubt. So basically, all this right, we are applying on key value pairs, right? So
Yes.
when you see like reduce by key, sort by key, map values, right? It
Mm.
automatically recognizes what is the key and what is the value. Based
Yes.
on that, we are applying that whatever the summation, right?
Yes.
But in the group by key,
Mm.
what we are doing is first of all we are getting that iterable object, right? There is not specifically identifying that what is the key. There also it can do the similar way, right? Is there any specific reason why it is not identifying that each lambda or I mean, each object, each key, and so doing if whatever if you want to do summation or if you wanted to bring
Here
max
also, if we
like
see in
grouping by
in that group by key also, whenever I say group by key, here also, yes, it is grouping all the 11 and it's aggregating this. You got this right?
yeah. I mean
Yeah.
here
All
yeah
the
here is we are not applying this lambda, right?
just like reduce by
Lambda
key,
x like that we are
just like reduce by key, you are getting this key and this output. Here also, yes, we are not going to perform this in group by key. We don't no need to provide anything. Just group by key functionality internally, it groups all the department number 11 similar, right? And aggregate all the how many department number 11 are there? One, two, or if any. It aggregates just this 10,000, this 50,000, everything. It will group it. It internally performs all that. But here for reduce by key, we need to provide this. But group by key, nothing is required. So automatically it groups, it won't aggregate here. Why here in reduce by key we have given means we need to aggregate it, express why I want. But here I'm not aggregating in group by key. Just to group it, that's enough.
So here map for map values, other than addition, subtraction, can we do any other?
Map values means just you are mapping some transformation to each value. That's it. What is the name itself saying map values, right? Mapping some transformation to each value. So the same functionality using map, how can we do? Using map. The same thing
I
using map.
think x of 0, x of 1 plus 5,000.
Same output I want to get. Same output I
Yeah,
want to get. Just observe this. This is your RTD. This is your RTD. Try to say, I want RAS2, a new RTD to be created. From
yeah.
this R1,
R1 dot map
R1, so R1 values, whatever R1 values are there, right? R1 means the R1 output map with, okay,
lambda
lambda, lam,
x
lambda x. What is this lambda x means? Each element is what here? Each element is one tuple here.
tuple.
Each element is one tuple here. From the tuple, okay, what do you
So
want? Okay, I'm giving one more. I want a tuple format as the output. What you want to extract? X
x
of
of
0.
0,
X means each element means each tuple. In that x of 0, take as it is, department number. And but the
x of
value
1
x of 1 plus
plus 5,000.
5,000. That's it. For each element to perform the same thing, right? Close it, close it. The same thing. But here, map, this is how we do using map. res2 dot collect. You will get the same output.
So is any specific any difference between map values? I mean, map can be applied on each element, but map values is more of like
Map
key
is
value based, right?
map is map is you want to perform transformations either means either any tuple element, it can be first or second. Map values only on values only you can apply. But in using map, you can also apply for x of 0 also, right?
Okay, but
For anything, map anything, each anything you can map, but map values only to the values only you can.
performance wise, is there any specific
Not
like
no, no,
performance?
depending upon the situation, we need to use this functionalities. Only for values only if you want. For example, employee name and salaries only to the salaries adding something. But anything map functionality for key also, for this also, if you want, you can go with map. Map, there is no restriction applied to each and anything you can. But for map values, only for the values only you can add. So in every example, most of the examples will be using map. Can you see here? In this also map is used. Each element transform aggregations, multiple aggregations. And here also, if you see in the previous. Mhm. Mhm.
Vijay, is it possible to add 5,000 only for the 0th and uh, second element, or is it possible using map?
Using map means each element, whatever you
Each
want,
element.
whatever you want to apply the transformation to each and every element, it is going to apply each element transformation map. Here
Okay, so
first one we have seen that map for each element transformation, whatever transformation will apply will be applied on each and every element.
okay, fine.
Okay, map values. Next, what are that? Next is keys. We have got keys. We have got keys and we have got values. Very simple, keys and values. These are inbuilt.
A short why how to do descending order like you did in ascending, right? If you want to do in descending order.
Sort by keys, no, only in ascending. Hmm. You will get only in ascending. Descending not pass. Sort by key by default, ascending. Based on key, all the keys in ascending. Returns, keys returns the keys of a RTD. Returns the keys of a RTD. Same example, right? R is result equal to R1 dot keys. What are the keys here? It returns all the keys. RES dot. RES is what? RES is what?
RTD.
RTD. RTD. Collect. So it returns only the keys 11, 12, 13, 12, 11, 13. What? Only the keys. Same way for values also. Values. Returns the values of an RTD. RES equal to R1 dot values. R1 dot values. RES dot collect. 10,000, 20,000, 30,000, 40, 50. Only the values, right?
So if you want to print this in descending order, suppose these values, then what we should do?
These values, if you want to print in descending order, you can print. Print.
Okay, then Python function we have to use, right?
Yes, yes. It's X is the not to know. Store this. Okay, if you want res dot collect, store in one variable X. X is a list. X dot.
So res.collect is a Python object. Then later it converted to the list, right?
X dot reverse print X. Descending order. Right?
Yeah, I think first we need to sort in Python and then we can apply
So
the
if
case, right?
you got once you got that in ascending order, if you want in descending, right? Reverse, there is a in Python we have got a reverse available, right? We can reverse it. So sorted of list means in ascending order. Sorted of list in ascending order you will get. So multiple ways in Python, sorted function is there, sort method is there, sorted or comma, reverse equal to true is there. But if you got already in ascending, just reverse that, you will get in descending. So the final output will be in anyhow in Python, right? If you got apply any Python related functionalities. Joined. Have you got, do you know that knowledge on joins, right? Everyone. Join. What do you mean by join? Inner join, left outer, right
Yeah.
outer, full outer? Yes. Join means mm, A equal to 1, 2, 3, 4, 5, 6. A is one set. B is another set, like 1, 2, 3, 7, 8, 9, right? First, inner join. What do you mean by inner join? Inner join, only the match,
Common element we want.
only the matchings. What is the output? 1, 1,
2, 3,
2, 2,
2, 2, 3, 3.
3, 3. 3, 3. Left outer join. Left outer join means what? Matchings. Matchings plus unmatched of left side. Unmatched of left side. Total presence of left side. This total presence of left side. Matchings plus unmatched of left side, that is total presence of left side. Try to say the output. Everyone. Matchings means first these are the match. These 3 are the matchings. Yes. Unmatched of left side is what?
4,
4, 7, 4, 5,
4, 5,
4, 5, 6.
These are not matched, right? So unmatched of left side. Total presence of left side you can see here, right? Total presence of left side you can see 4, 5, 6. Yes. Next, right outer. Right outer join. Right outer join means matchings plus. I'm copying.
Match your right side.
7, 8, 9.
Matching,
Unmatched of right.
matchings plus unmatched of right side. Unmatched of right side. This total presence of right side. What are the unmatched of right side?
7, 8, 9.
7, 8, 9. These are unmatched. Okay, unmatched. And this full outer join. Full outer join, right? Matchings plus unmatched of left side. That is total planes of left side plus full outer means total unmatched of left side and unmatched of right side also.
Everything.
Matched of left side and unmatched of right side. That is total presence of right side. 1, 1, 2, 2, 3, 3, and 4, 5, 6, and this unmatched of left side and unmatched of right side.
So basically everything.
Yes. This is matchings, unmatched of left side, unmatched of right side. But here in our joints, right? In our joints should be applied on key comma value pair. Should be applied on key comma value pairs, right? Yes. For example, observe this. R1 equal to SC dot parallelize, right? SC dot parallelize. Just check it. I've got a list of tuples, because on key comma value pairs only it can be, should be applied. 10, 20 is 1. 30, 40. Yes. 50, 60. R2 SC dot parallelize 10, 20, 30, 40, 70, 80. First one. Inner join. Inner join means only matchings. Only matching tuples. What is the output you get? IJ. IJ means inner join. The name I'm giving. R1 dot join. R1 dot join. R2. What is this IJ? What is it? Say Python object or
Inner
RTD?
join.
IJ, RTD, right? IJ is an RTD because it's a transformation applied. Okay. IJ dot collect. How will you get this output, right? How will you get this output? This 10 is there, right? Key for both the key is same. Key 10, 10, come, you will get output in this way. Just observe. Not like, just check this. Output will be, you will get what is the 10 is the key. 10 is the key. Keys only takes first. Keys. Values S 20, 20. This is what? A match. 10. Only 2 are there. And still, what are the keys that are matching? What are the keys that are matching here?
30.
30 also.
One more. 30. One
40,
tuple.
40.
All the
40
matched
comma
ones.
40 comma 40.
40. Still, if you got many, all 40, 40, 40, it will be displaying. You'll be getting output as the list form. This only matchings in this way.
So basically, joining is based on the keys
Key.
only,
Joining based on.
whatever the value.
So 10, 20, 20, 30, 40, 40.
So here you are giving ij. So if you give ij, it will automatically system will come to know
No,
ij.
ij is any name you can give. That is
Okay.
not it's not any built-in functionality. ij is just a name. Previously res you can give instead of ij.
Okay, got it.
So why it is saying 2020 for 10 it is just 10 and then next it is saying 2020 and 30.
So how the join happens based on key only. 10 based on 10. Any match is there for 10 and 10? Yes. Why it has not taken 50 and 70? There is no match in for 50 key. 70 key also there is no match.
Okay, so 10 is a key, right?
10 is the
Okay.
key. There is a match, right? 10, which are the 20, the values as 1. If one more 10, 20 is there, means totally you will get 20, 20, 40. Here, this is also, assume this 30 is 10. You will
Can
get
you change the value like for 10, 10, just put a different value 20, 40, 20, 70 or 20, 80? You put same value, so I'm getting confused actually.
Okay, 1 second. Delete this. Delete this. Control L. Okay, R1 will be the same. R2 will be different. 10, 25, 45. Hmm. $70, $80. Now, check it.
Can you give one more 10, maybe 35?
Ten, comma,
Maybe 35. Yeah, or whatever. Yeah, that's it.
So it's R2.
yes. We get confused, give it as inner join result is what is that output you will be getting for this, everyone? 10 will be the key.
20, 25, 50.
30.
10 for 10, 20, comma 25.
Hmm.
For 30, 40, comma 45.
But-
Sorry, 10 for 10, 20, 25, 55.
30,
40, 45.
40, 40.
10, 20 and 25. And this again with 10,
20 and 40.
20,
50.
20 and 55. This one. These two matched and this are matched. Yes. Separately it is taken. 10, 20, 25, 10, 20, 55. Yes. 30, 40. If one more match is there, again 30, comma, one more tuple you get. Only
No,
match, only
Jay,
matching.
generally, if it is image join, right, 10, 5, comma, 20, 25, 55, we need to do it. Why it is stated on another part?
10, no, one more
Don't
tuple you are
compress,
put.
it's on the control.
All the here, this and this. Again, this compared with this one, is it a match? No. This and this, is it a match? Yes, 10 and 55 you get. 20 and 55. This again, you do this one. No. 30 it compares with each and everything, right? 30 and only for this it is a match, right? Now check this with left outer join now. Right with left outer join. Left outer join. Matchings plus unmatched of left side. Matchings plus unmatched of left side. How left? Okay, left outer join, right? Matchings plus unmatched of left side, right? Check this. LOJ underscore RES. Left outer join underscore RES. What I should say? R1 dot LEFT, left, O in uppercase, left outer join, J also in uppercase. Left O in uppercase, J also in uppercase, left outer join. R2, left outer join of R2, right? Yes.
Hello.
Left outer join, right? Check this output, right? If I say LOJ underscore RES dot collect, what is the output you get for this? First, you will get the matching, same that previous one you will get. Apart from the previous one, right?
50, 60.
What you will get? 50, 60, comma, none you will get. So, yes. None. 50, comma, 60, and none you will get. 50 is the key, right? 50 is the key you will get. This one, 60, comma, right side, there is no match. That's why none you will get. 60, comma. See here, this 50 will come like this. And this 60 comes here. Right side, there is null value. So NONE, none you will get instead of it. Just check this. 50, 60, comma, none. Remaining 3 as it is, like previous one. 50, left outer, okay, you will have a value. But right side, null. Right outer join.
Now, how it's displaying actually? It should display the 30 before the 50 actually. but I can see that it's 50 unmatched is displaying, in between actually.
It has to display, right?
Yeah.
Total presence of left side is there or not? Total presence of left side required. 10 key should be there, 30 key should be there, 50 key also should be there.
But here
No,
30 is the second one,
Total
right?
presence
But
of left side.
how it came in the last? That's what his question, I guess.
yeah.
Right outer join, matchings plus unmatched of right side.
And also, Vijay, how can you give the real-time use case for this kind of things so that it will have a clear picture of this?
Just I'm discussing about the transformations, right? How there can be used key comma value. Matched plus unmatched of right side.
No, I mean, in which use case these kind of things can be used actually? That is the mode of my question actually.
For example, okay. So here, for example, employee 1 is employee 1 EMP2. Two are there. This is from Hyderabad branch. This is from Pune branch. Two are there. So, for example, okay, other was EMP1 and EMP2 data is there, right? Two data are there. EMP1 and EMP2. Different cities data are available. In EMP1, this employees data are there. For example, okay, Hyderabad, this is Pune, two branches. I want to check in Hyderabad, in marketing department, what are the sales, today's transactions, marketing department or accounts department. So think that you have got some department numbers 11, 12, 13. This is marketing, this is finance, this is accounts, right? So okay, for example, 11. So here it will all that department 11. If you perform some kind of join, department 11 is the key, and all their values you will be seeing here. All the values, how many values? Similarly, if department 12 matched ones, department 13 matched ones, you'll be seeing here. 11, 12, and 13. You are performing joins. If you're performing joins, right, all the department number 11s, because if EMP1 and EMP2, if you perform inner join, department 11, what all the values you will see, department 12, what all the values, 13, what all the values are there. If you perform full outer join, even unmatched ones, 11 matched ones, you will say, if any department number like 15, 16, 17 department numbers are there. So department 1 doesn't, none indicates what? The branch 1 doesn't have any value for it. And here branch 2 will have the values. And here first one, here you have got value, here you have got a none. Means what is your understanding? In branch 2 doesn't have, in branch 1 you have. Here in branch 1 doesn't have, in branch 2 you have, right? If you talk about instead of these department numbers, if you take products also, LG product, Sony product, or Samsung. products if you take, other than, okay, if you're taking some products, right? LG product. If there's branch 1 and branch 2, both are matched ones. LG, and what all the transactions related to LG. Sony also, what all the transactions related to Sony. Samsung. But if there are, for example, there is a product like MI. MI is there. Here you can see MI is the key. MI is the key, right? And here value is there here. In the second branch, none is there, means what is your understanding? In first branch, Hyderabad branch, MI is available. That in branch 2, this MI is not available. Here, for example, here another product. So these all are matched ones. These are unmatched one, means, for example, any other like OnePlus. Here none is there. Here you are getting some value. None and value means here in branch 1 it is not available. In branch 2 it is available. In branch 2. But here LG, Sony both available in all the branches. Both the branches. If you are performing full outer, you will get this. If you are applying full outer only, you will get this. Full outer means matching unmatched of, this is unmatched of, this is result of left outer join. This is the output of right outer join. This is inner join combination, right? This is full outer join. So all the products, right? So what are, you can clearly understand. And here you got tuples, right? What is the total revenue generated by each product? The later you perform map operation and just perform sum on this, right? You will get this. So whenever you perform these joins, right? Joining the values of both the RTDs. What is the join operation doing here? If for a particular thing, it is joining the values of both that. Key is there, but values it is joining. Values it is joining. If there is a match. If there is not a match, it is performing in this way, right? Okay. Observe the behavior of this inner join, left outer and right outer, right? Here, keys it is taking. It is taking the keys and the values. It is combining. So here for 10, left outer join, the same matchings will come. The same matchings are you are going to get. Unmatched is only one, means the key is present in the left outer. Right side, none. This means this 50 key, this is not available in the right side. Okay. Right outer matchings plus unmatched of right side.
And Vijay, suppose if I wanted to do the summation, right, for the department number 10, for what are all the values we get, 20, 25 plus 55. But here we have two tuples, right? In that scenario, I mean, how do we get only those three values to this one? Because for department number 10, we have only these three values matching.
So here, just before we have seen, right, reduce by key.
Yeah, reduce by key.
Reduce by key.
Yeah.
All tens it will group and it will aggregate the values.
Yeah. But here, right, we have
now you
10,
need to
20,
apply now 10. If we are applying reduce by key, right, now on this, what it will take all the keys 10, 10, 10, other values will be, otherwise group by key. Group by key, if you are apply, you can perform all aggregations. It will group all this 10, 10, right? This 10 and these values will be grouped.
My only point is the values 20 is getting repeated in both the
But
terms. Right?
okay,
The summation is not wrong, right? Actually, it should be like 125 plus 55. Yeah. So 35 plus 55, 90, basically. But if I do whatever you said, right, reduce by key or group by key, then I will get like for this 10, 20 plus 25, 45, plus 20 plus 55. Like that it will be added, right? Hello.
Yeah, I'm checking. 10, 25, 25, key. If you're applying reduce by key in this case also, what happens is the key 20, 20 will be added for 2 times, right?
Yeah. Which is wrong, right? Actually, while doing the summation.
In this case, we can only perform joining operation only. Aggregation you cannot perform. If you aggregate using reduce by key and group by key, you will be getting that keys duplicated. No. Aggregations you cannot do in this. You can just performing some join operation. Keys in this way.
But finally, at the end of the day, right, what you said,
What
right?
was it?
If I want to check the department wise, if I want to check the sales, right, then I need to do the summation. In that scenario, is there any different way? Instead of using the join method.
So you'll be getting there also, if you are getting right, LG, for example, 30K, 20K you will get from branch 1, branch 2. One more LG you will get with 50K, 60, 70K. If you have got time. In this way, different LGs you will get like this. LG 30 will be there. 30 and 70 you will get. 30 and 80 you will get. In this way you get.
Yeah, but if I need that sum of the sales, I mean, sum of for each LG, right? I want that for this product, what is the total sales happened? Then I need to sum it based on 30K plus 20K plus 70K plus 80K, right?
So in this case, right,
So,
using a map functionalities, you need to extract this 20, this 70,
so okay.
this 80. You need to do some more many transformations using map. After this, directly by using reduce by key, group by key, what happens is this 30, this 30, this 30 will be repeated for 3 times. If you apply reduce by key or group by key. In that case, you need to extract this and this. Then, sir, if X means this each tuple, X of 0 means this product. X of 1 means this one. X of 1 means this tuple. X of 1 of 1. X of 1 of 1. You need to just extract this X of 1 of 1 from each tuple. So from each tuple, you can need to perform this transformation. Directly reduce by key, group by key won't work.
Yeah.
So from each, okay, X of 1 of 1 unit. Right outer join. ROJ. Right outer join of R2. Here you will get a 70, you will get. The previously 50, 60 none you get, but here you will get 70, none comma 80. Okay, just check this. ROJ underscore res dot collect. 70, none comma 80. All the remaining things are matched. This is unmatched. You will get this 3 you will get, this 50 you will get, 70 you will get, totally 5 you will get. FOJ. Okay, this is joins. So this is transformations, right? Normal transformations and the key comma value paired means which transformation you need to apply on normal RTDs. Here, just observe this. All these should be applied on only on key comma value paired. And this can be applied on any RTDs. This can be applied on normal RTDs. This on key comma value pair. Next, actions. Next is actions. Okay. Various actions means you'll be getting the Python object, various actions. Whenever action is performed, the flow executes from its root RTD, The following are some of the actions. The following are some of the actions. Collect, count, by key, like sort by key, reduce by key. We have got count by key, count by value, B capital, V capital. Take, top, just like we have got first, just like reduce by key, we have got reduce here. Sum is an action. Max is an action. Min is an action. Count is an action. Save as text file. Save as text file as path. Okay. So these are the different actions, right? If you are performing any of this action, then the entire data flow gets executed, right? Collect, right? It will collect all partitions of different slave machines into client machine. X equal to 10, 20, 30, 40, 50. I got some list. I want to create an RTD, R1. SC dot parallelize of X. R1 dot collect. Okay. Collect means it collects all that elements, right, of an material. Count.
So here, what is the difference between the X and the last you did collect, you performed action, right? What is the difference between them? Both are Python object, right?
Yes, R1 dot collect, whenever you perform some kind of action on this, when you're performing some kind of action on RTD, the result you will get a list.
Even instead of R1 collect, if you had a result of R1 also, the result will be same, right?
R1 will be same, R1 dot collect also will be same. Just you are collecting all that data of that particular RTD. R1 dot collect. R1 will be the same, R1 dot collect will be same, X will be the same here.
Can we pass tuple into X, like 10, 20, 40, 50 tuple form?
Just tuple also you can pass. Any collection, right? Any collection is fine.
So if we print R1, then it will be RTD only, right? If we
Yes.
say print R1,
Print R1, it prints RTD.
okay. The value will be same, right?
R1 elements are same. R1 elements, whatever R1 elements, right? Same elements, 10, 20, 30, 40, 50.
So print R1 does that command, right? It will not, right? Because RDD, you can't print that RDD.
R1 dot collect only, you can get the elements of it.
Yeah. So print will not to print the
Print
whatever
R1
the
means it will just print that you don't get that output. Count. Counts the number of elements in a RTD. Same, you can say R1 dot count here. R1 is an RTD. Only on that RTDs we can apply this actions count. R1 dot count is what? 5 elements. Third, count by okay. Count by key and count by value. First, I'll discuss count by value. Count by value.
So what about the count, action? This will be also collect the value from different slab machine.
Yes.
So all the actions method it will be collect from the value from the different
It
slab
will
machine.
only counts how many are there, how many elements are
From all the partitions of the slab machine,
there.
right?
Yes, it just prints that how many are there. Count only it gives. It won't give that value, but only the count how many elements in an RTD. RTD has got how many elements. Five elements. Here R1 is an RTD. R1 has got what? 10, 20, 30, 40, 40. How many elements? 5 elements. Okay, count by value. Counts number of times. Counts number of times each value occurs in a RTD. Counts number of times each value occurs in an RTD. But here count by value or count by key. This count by key, count by value, both returns a dictionary. Returns a dictionary. Always this collection, whatever these actions gives Python objects only. always the output of this actions is going to be Python objects like dictionaries, integers, lists you will get. Here you got list, here you got integer, here you will get dictionary. Count by value. Just observe this count by value. Okay. For example, today, okay, so students from different branches, they are attending the interviews, right? Students from different branches. EC branch. Otherwise, okay. For example, toppers. Top 10 toppers of the college. Count by value means, for example, okay, for example, Olympic medals. India has won. Australia, England, India. Some medals. Some medals, right? Okay. R1 dot R1 equal to SC dot parallelize. First, parallelize it. Assume that you got an RTD. In that RTD, you got 8 elements are there. I just want, in this way, you got some 500 medals are given. 500 medals are given in this way. The big list you got, the big RTD you got. In that, I want to count how many India has got, how many Australia has got, how many England has got. Think that some 5 countries are there. 5 countries, 10 countries are there. 10 countries, they have won like 500 medals. So which country has won how many medals? So for that, R1 dot count by value, count by value. R1 dot count by value, right? Yes. Like, see how many India, 4, Australia 2, England 2. So you will get a dictionary here. Four. Count by key. Count by key, right? Counts.
So here count by value means it cannot it is key value pair or medals you
No,
see,
no,
right?
no,
It's
no,
a
no.
list.
No. Here, no, here it doesn't have the key comma value. You can perform, right? It should be an RTD. If you want RTD dot count by value, whether it's a It's not that it should be a key comma value. No.
In that case, right, what if metals is a key value pair? So what will be the dictionary then? It is a value count or
For
key.
example, for example, okay, you want to perform on this key comma value. Okay. R1 is an RTD that is created by saying sc dot parallelize of a list. In that list, you got, for example, from different cities, a seminar is attended by different people, right? So first person is from Hyderabad, male. Hyderabad, male. Pune. So assume in this way, we got key comma value pairs, key values, right? R1 dot count by value. Count by value, right? Yes. Okay, count by value. Count by value means Hyderabad males how many? Pune males how many? Hyderabad males 2, Pune males 2 you will get. Yes. The same thing you can apply for the next one also. So key comma value pairs means how many Hyderabad males? Pune males. Count by key. Counts number of times each key has occurred. But for this count by key, right? This is applied only on a pair RTD. Only on a paired RTD. This is applied only on a paired RTD. Now, Control L. Here I am just including some more. HYD, female. Pune.
Paid adding the investments like is key value, right?
Pune female. Hyderabad male and females are there. So in this way, right?
The comma is missing. Comma is missing.
Where? Okay.
So in the last double before that.
It counts only the keys, right? And gets a dictionary. It also returns a dictionary. R1 dot count by key. Count by key only. Whether it is male or female, how many from Hyderabad, how many from Pune. Hyderabad 3, Pune 3. Count by keys only. This you can apply only on key comma value pair only. You cannot apply on normal entities. It also returns a dictionary.
Suppose if I want to check, right, for female, Hyderabad females, what is the count? Pune females, what is
For Hyderabad,
then?
Hyderabad,
Yeah, for Hyderabad, I want to check what are the, how many males are there and how many females are there separately as a two different things.
so you can see that count by value, you can see what's out, right? Count by value.
Okay,
Hyderabad males how many? Pune males how many? Similarly, Hyderabad females how many? Hyderabad, Pune females.
yeah, value generally it gives based on the value, right? Count by value.
Take off n. Takes first n number of elements. For example, employees. Employees equal to sc dot parallelize. Some top 5 employees are there. That's it. EMPS, right? EMPS dot take two means what two it takes? First two. First two only. Take the first two. Just like take, we have got one more like top. Like top n. Top take n and top n both are different. Takes top n elements. Takes top n and n elements. From a OTD. From a OTD, right? For example, salaries are like this. Salaries are sc dot parallelize list of 10,000, 20,000, 30,000, 40,000, and 50,000. Sales right? Take two means what you get? Take two means what is it?
10,000.
10,000, 20,000.
Sales right. Top two means what?
40, 50.
50,000 and 40,000. Top is first. Top is what? 50,000. Next 40,000. Topmost. Understood? Take means 10 and 20 you got. Top means 50 and 40 you got. Topmost. Take means whatever comes first to it takes. Top means topmost salaries. Topmost salaries if you want to. Take means first to whatever whoever comes. For example, in the same way, if I apply for this, EMPS dot take two means Ajay and Rohit you will get. But top two, if I say, top two means what is that you get?
Based on the ASCII value.
Based on ASCII values, right? Which is the highest ASCII value here? Or what is the output you get? A has got the least one, Z has got the highest ASCII value. A has got the least ASCII value, Z has got the highest ASCII value.
MR,
Rohit
Miller.
and Rohit
Miller.
and
Miller.
So, yeah.
Rohit and Miller you need to get.
Suppose if the Miller is removed, right? We have James and John. So J and J they have both the same value, right? Then it will go
James,
for the next.
John you will get.
Yeah, next alphabet.
That's it, next alphabet it checks.
Each top can be applied on key value where in the
No.
no, take we can apply, right? Since it's just take
Yes,
the name,
yes,
we
yes.
can apply that.
First two tuples it takes.
Okay.
First is there. Takes first elements. Takes first element of a OTD. EMPS dot first. Okay. The remaining thing I'll discuss in the next session, right? So it will in actions, different actions, and next I'll go with partitioning, increasing the partitioning while parallelizing, coalesce function. How can we combine? How can we increase the partitions, decrease the partitions, right?
Also, can you cover the config file where we define all the memory elements and everything?
What is it?
So we have, I think, configuration file, right? When we automate something, there will be one config file where we define the how much memory is needed, like RAM is needed, and I've seen those failures in Spark where RAM is like sorted when we get more data.
Okay, fine.
Sir, Spark in local Jupyter notebook. So is that done, sir? So actually, in 2 classes I was absent.
So yes, we can execute these things in Jupyter Notebook also. How to, okay, means how to, do you want like how to install this in Jupyter?
Yes, sir.
Okay, so yes. In the next session, I'll show you, right?
So can we perform all this whatever coding we are doing in the Jupyter notebook also, right?
Yes, we can do this.
Okay.
Okay, I'll forward these notes in the WhatsApp, right? Yes. Whatever we discussed, we'll continue in the next Saturday, right? More discussions.